Hello, check, test. Hello, hello, check. Hello, hello, check. Hello, hello, hello. Hello. Hello, check.
അതവിടെ അവിടെ ടെസ്റ്റ് ചെയ്യുന്നുണ്ട്. സൂമിൽ മ്യൂട്ടാണ് നോക്കി. അല്ല ഇവിടെ അൺമ്യൂട്ട് ചെയ്ത് അതിലാവുമല്ലോ. ഹലോ ചെക്ക് 1 2 3 ഹലോ ഹലോ അല്ലേ? ഇത് ഓണാക്കണം. ഇപ്പൊ ഓഫാ. ഇതൊന്നും ഓണോ? ഇപ്പൊ ഓണല്ലേ? ഇതൊന്നും ഓണാണോ? ഓണോ? കുഴപ്പമില്ല. അതൊന്ന് touch ചെയ്തോ.
Good morning, my dear colleagues, students. On behalf of IIT Palakkad fraternity, it's my pleasure to welcome today's colloquium speaker, Dr. C. Mohan. Dr. Mohan has a rich CV with a lot of accolades. He is a proud alumnus of IIT Madras. So there's a lot of connection with IIT Madras here also. Either PhD, MTech, or even faculty exchange. And received PhD at the University of Texas at Austin in 1981. So some of you are not even born. He was an IBM fellow at IBM Almaden Research Center in Silicon Valley for nearly 39 years. In the database, blockchain, artificial intelligence, data science, and HDAP technologies, and other related areas. With IBM, he has invented well-known various family of database, locking and recovery algorithms, and presumed about distributed commit protocol. In addition to receiving ACM Sigmund Edgar Code Innovations Award and numerous IBM awards, Mohan was elected to the US and Indian National Academies of Engineering and named an IBM Master Inventor. He has served on the advisory board of IEEE Spectrum and on numerous conference and journal boards. He was a short visiting professor at National University of Singapore. Mohan is an inventor of 50 patents and is a frequent speaker in North America, Europe, and Asia. Currently, he is a distinguished visiting professor at Tsinghua University, China, member of Board of Governors at Digital University, Kerala, and also advisor for Tamil Nadu E-Governance Agency and Kerala Blockchain Academy. So you can see that a lot of accolades and quite high rich CV. So thank you, Mohan, again. We will look forward to talk.
Thank you very much. Gives me great pleasure to be here. I was hoping for the in-presence presentation rather than doing a virtual one. I'm tired of doing these virtual presentations. So when Sunil said maybe there won't be that many people and all that, I said I still prefer to do the in-person. And also this gives me an excuse to show up to one more IIT. I've been to the first 5 and then went to Guwahati. But since then, I don't think I've been to any other IIT outside of the 6. Roorkee, maybe I've been to, but before it became an IIT, I can't recall now. So this is the first one amongst the next crop of IITs that I'm visiting. Plus, I have an added pleasure. I wish my parents-in-law were alive. My father-in-law grew up in Palakkad. So even though my wife herself grew up in Chennai and Tanzania, my father-in-law grew up in nearby town. And so in that sense, there is a family connection too. So, and my wife is floating around doing something today. Thanks for hosting me. We are staying in this Tharawad place, which is really, really nice, Kanda. And so as Jagdish mentioned, I've done a bunch of stuff. So I'd like to think of myself as not just a research guy, in the sense of ivory tower research, but somebody who has focused more on practical research, even though technically I was part of IBM research my entire career of 38.5 years. Even when I was the IBM India chief scientist based in Bangalore for 32 months, I still didn't take up any management position. So all these years, I've been a non-manager, so individual contributor. As a fellow, of course, I got to get involved in many things. It's the highest technical position you can reach in IBM. But of late, of course, since I retired 1.5 years ago, I had been wanting to do more things that I couldn't do as an IBM because of whatever you sign away your brain to IBM or any company for that matter when you join a commercial organization in terms of being able to collaborate across different companies and things like that. So I thought I'll do more, but then this COVID thing came in the way. And so the only thing I could do in a serious way was going to Singapore, where things were much better than they are now. So the minute we left at the end of June this year, things went crazy even in Singapore. So for the first time, I was responsible for a course. I had never been a teacher of a regular course as such, but even this thing that I did in Singapore was more a seminar course rather than a regular course where I had to prepare slides for the whole semester and so on, but it's still a unique experience. So this topic, I'm no expert, but I like to think of myself as somebody who does information gathering and shares it across the globe all the time and so on. So, but as an undergrad studying supposedly chemical engineering at IIT Madras, 72 to 77, when there was no place in India where you could do an undergrad in computer science. When a mainframe came to IIT Madras in 73, at the beginning of my second year, I got hooked, even before I got into chemical engineering proper, which used to happen in those days in the third year on. First 2 years were common across all the disciplines. It was a 5-year BTech then. So I had to while away my time doing chemical engineering just to finish my bachelor's before I could get formally into computer science, which I did by going to University of Texas at Austin. But during those days itself, IIT Madras days, I was well aware of the work going on in many places, especially Carnegie Mellon, Stanford Research Institute, and so on, in the area of AI. So I felt with all the current hoopla in the AI context, too many people think that AI equals machine learning or even more narrowly deep learning. So I want to, first of all, make people realize there's a lot more to AI than just that. Also, don't think that deep learning has solved all the problems that are there. So it's in that spirit that this presentation is going to cover a bunch of material. There'll be lots of links to various reports and such. I strongly recommend that people that are interested in the topic follow up on those things, because it's unlikely in a single place you'll find the kinds of links I've managed to gather up and put here. And in particular, if you find my presentation somewhat interesting, there's more discussions in the web about my last presentation, which you see the information on here. It was a few weeks ago in Crete, in Greece. There was a lot of Q&A and all that at the end of the presentation. So you have the access to the slides as well as the video of that one. So this report by Arvind Narayanan at Princeton is an interesting one. You can go read more on why he thinks it's become like snake oil. People claiming all sorts of stuff can be done using quote-unquote AI. Even things like, oh, we'll look at the face of the applicant as he or she is interviewing, and we'll be able to tell you whether this person would be a good employee. Totally bogus things of claims. But it's become fashionable, just like, where I come from. 4 decades I've lived in Silicon Valley. And every day, some VC or a startup person will make some tall claims about what they have done now, what they are doing is going to change everything. And the latest fad, buzzwords will be used to claim that what they are doing is the greatest thing on earth and so on. So, see, it's along those lines that this AI label is being slapped on all sorts of totally inconsequential or not related topics just to get attention, funding, glory and all that in a illegitimate way. And there is also this other thing that both academicians and Silicon Valley type people promote, which is whatever applies to the e-commerce giants, the social media giants, applies to every damn organization in the world. This is also bogus. Don't think that all organizations have the gobs and gobs of data that Facebook, LinkedIn, and so on, or for that matter, Baidu, the Chinese companies have managed to accumulate. The average organization anywhere, not just in developing countries, but even in the developed countries, don't have anywhere the amount of data that everybody talks about when they discuss big data, petabytes of data. That can easily train a machine learning algorithm to do whatever they it's a possibility. So organizations vary in size. I gave a version of this presentation for the inauguration conference of the digital era. They were focusing on organizational revitalization or something they called it. So I said, there are B2B, B2C, people to people, government to government kind of organizations where the number of entities involved is unbelievably small compared to the billions of people using Facebook and such that you'll hear about whenever anyone wants to hype up big data. And so what applies to those companies don't necessarily apply to you. And also, another important thing to keep in mind is they justify spending unbelievable amount of resources in terms of compute power or storage or whatever it is, right? Not based on the direct money that they can get out of doing whatever they are doing, recommendations and so on, but based more on advertising revenue. But the average organization is not getting money for advertising, okay? So you really have to justify, if you're making a recommendation and somebody's paying for it, how much money can you really afford and still make a profit and all that? So from that perspective also, it's important to keep in mind that you just cannot do the kinds of, billion parameter models of this and that. It's fashionable to talk about. And the academicians are also getting hooked by some silly benchmarks, recognizing caps and so on, as if that's the most important thing in the world to worry about. So these benchmarks are also a problem at times because they focus you on the wrong thing in terms of practicality and usefulness and such metrics. And at the end of the day, what data you're going to use to train these models and how good that data is, how fair it is, and all that is also an important thing to think about. So it's garbage in, garbage out. You can train the model with some subset of the data that's relevant only for a subset of the ultimate user population. Then what you get will not in any shape or form be useful for the bulk of the people that you didn't care to take information about and train your model. So as a database guy, by the way, it wouldn't have been obvious from what was said before. My research group, before I joined IBM, so I don't get any credit for it, is where relational database concept itself came from, meaning Ted Card was my colleague for 2 years after I joined. So he was there when we did the original relational model work for which he got the Turing Award. Also, the System R implementation of that original model that resulted in the SQL language coming out also was part of the same department in San Jose. And the person who hired me, my first manager, Patricia Selinger, she is world-renowned as the mother of cost-based query optimization. So we have a rich history, and bulk of my time in IBM I've spent in the database area. All this AI and blockchain and all that is a more recent dabbling I have indulged in. And so for us, as a result, the importance of data is something that shouldn't be forgotten in all your algorithmic explorations and so on. So there are, of course, lots of risks associated with AI that you should be cognizant of. You cannot just say, hey, this black box told me that your mortgage application should be denied or your claim for some insurance should be denied, and hey, just believe me, you did the right thing. That just won't cut it. You can land up in lawsuits and all that because you are unable to explain what are the things about your case that resulted in that thing. So a lot of this deep learning stuff is like that. So you have to worry about explainability and such, especially if you're saying somebody has cancer based on some inputs that were fed into a black box model and so on. And then there are, of course, other considerations depending on the country and all that they worry about it or not worry about it. Things like privacy. China doesn't care a whole lot about that. So even facial recognition using computers is not considered acceptable. IBM chose to actually get out of that business of producing face recognition software and such. And of course, military usage and worrying about unemployment and all that are important things to think about as you do things. And of course, the deep fakes and fake news and such are also a big factor. These days, it's hard to tell whether something was generated by humans or by algorithms. So then there is this big one about environmental cost of large models that people are not talking about. You'll see later some numbers to back why, there is even far more worrisome need for increased compute power with some of these models. If you choose to consider them to be worthy of being worked on from a practical perspective, but some of these things are being done in the gaming context and so on, which is not necessarily your bread and butter, life preserving kind of activity. So, but still, you do need to, and this is similar to the nonsense that's going on with mining that's happening in the blockchain space, for example, where they are blowing up incredible amount of energy. And you get into these sorts of headache-causing situations where the Googles and the Facebooks of the world are being really bad. They claim that they are trying to help society and do bad things and such, but in fact, when they appointed some people to worry about fairness and such, they actually wound up firing some of them. This black woman, what's her name? Timnit. She got fired. And so I highly recommend you go read some of these articles to find out more about how even the guy that was appointed in the case of Facebook to worry about fake news is not being given as much freedom, because there's always this dilemma between making money, losing customers, or increasing customers, and so on. However it's done, versus supposedly worrying about the bad things that are the consequence of some of these things, including, for instance, silly president America Trump and all that crazy stuff associated with him. So this is the point I already made, where you do need to think about the fact that AI has more to it than just deep learning or machine learning. And in terms of definition of what AI is, believe it or not, there's actually a law in the US, this National Defense Authorization Act of 2019, which came out in August 2018, that gives a definition. And you can read through it at your leisure, but essentially it talks about the fact that AI is an artificial system which performs some tasks under varying and unpredictable circumstances without significant human insight. It's not saying without any human insight, or that can learn from experience and improve performance when exposed to data sets. It's basically computer software, but it could also have some specialized hardware or another context that solves tasks requiring human-like perception, cognition, planning, learning, communication. Could even involve physical action, robots moving around and doing things and such. So there are, of course, cognitive architectures as well as networks that might be the way in which you accomplish some of this. And the system can act rationally, including an intelligent software agent or embodied robot that achieves goals using perception and planning. Okay. Later on, you'll see further amplification of some of these points in terms of how over the decades, in case some of you youngsters are thinking AI is something brand new, guess what? The phrase artificial intelligence is itself almost as old as I am, and I'm 66 years old. So it's 65 years old. 1956 is when this phrase was coined by John McCarthy, the Stanford professor, who got the Turing Award later and so on. There's another definition that an expert group on AI in Europe came up with. This again talks about software and possibly hardware, given a complex goal act in the physical or digital dimension by perceiving the information, the environment through information, data acquisition, interpreting that data, and then the data may be in the form of structured data or unstructured data, reasoning on that knowledge, and processing the information derived from this data and deciding the best action in order to achieve some goal. Maybe you want to move from here to there without getting knocked down, right? A robot has to move. And as it moves, if it does encounter some problems, it will then reroute itself. It's no different from when you're using GPS to travel and you were supposed to take an exit and you didn't, then the GPS algorithm automatically reroutes you. It says, okay, you missed this exit, you see person, now you have to take this other exit or make a U-turn, this, that, right? So it's those sorts of things that you need to think about. Oh, see, I didn't realize you were also seeing the position of this. Okay, I'll move it down. There are more things in terms of, this is called an operational definition. This is the European Union AI Watch entity that was set up that has this, report. So like I said, there are many reports that have come out and I have the links to them. So if you look at this, there is more stuff here. There is core, there is transversal, AI taxonomy in an AI domain, and then the subdomain and things like that. So if you look at all this, you'll realize there's more to it than just recognizing cats and pictures that are shown to you as the benchmark. So wherever you could employ software or special purpose hardware, you could think of making use of the AI technology. Again, you have to still justify spending the money and resources based on the return on the investment. So the Defense Advanced Research Projects Agency of the US, which is the entity that has caused major innovations to come about, including the internet and such, they have talked about the 3 waves of AI. And then they talk about a notional intelligence scale where perception, learning, abstraction, and reasoning are measured in a, not in a numerical way, but in an approximate way. And the possible different states are in terms of sophistication level, minimal, adequate, nuanced, and advanced. Okay, so you will see between the first wave and the second wave, certain things improved, but one thing at least went backwards. Okay, so let's go on. So the first wave is talked about as if it's a way of describing certain rules and such, whereas the second wave is doing categorization, and the third wave will be able to explain what that is. Okay. First wave is still advancing and solving hard problems. This is the more classical way of coding AI knowledge into systems and making use of it for a specific domain. The second wave is amazingly effective. This is all the current hoopla with deep learning, but it has fundamental limitations. That's important to keep. Okay, and the new research is shaping the third wave. And another way of looking at this, that the European, I believe it's called Joint Research Center, that the European Union countries plus some other countries have funded together. So they talk about the fact that AI got hyped a lot, and then there was disappointment. The expectations that were set initially were not lived up to. We worked on it. And so they call that the AI winter, the dip in the curve. So the y-axis is popularity, the x-axis is time, right? So interestingly enough, if you look at the first period and the second period, almost all the work was done in academia, whereas the third wave, the third period, as they call it, 1990s to now, it's a combination of industry and academia. And in fact, you'll find that the funding sources are also different now. It's more industry funded now than in the first 2 periods. And in terms of also the compute power, as you can see, there's been a dramatic improvement in terms of what was available for people to employ, and the cheapness of the computing power, storage, and various things that go with all that, right? And new kinds of hardware. But we are still far from having general artificial intelligence or artificial general intelligence, AGI. So it's also good to pay attention to people and places that are doing good work and so on, not just get carried away with only, counting number of papers published and things like that. Get inspired as youngsters, especially by the people and their background and so on. So pay attention to not just the technical aspects, but also where they came from. So along those lines, Turing Awards have been given for a long time. I forget now, the first award might have been in '64 or something. Over the years, these are the awards that have been given in the area of AI. So you'll see Stanford and MIT and Carnegie Mellon have had major contributions to make to the world. You'll see one Indian name. It turns out Raj Reddy is the only Indian to have gotten a Turing Award for any topic, okay? Not just AI. And he finished his bachelor's, I think, when I was 1 year old or something like that. So, and he is in the first batch of computer science PhDs coming out of Stanford. And so he and Ed Feigenbaum got the award in '94. That's a long time ago. And that man is still very active. He's the chairman board of governors of IIIT Hyderabad. Okay. So, especially those of you from Andhra should feel excited that the Telugu guy is the only Desi to have won the Turing Award. The latest, of course, was given for the people who did the deep learning work, right? And now you see even commercial entities showing up in this list, not just universities. I also felt, it's useful to look at sometimes certain things that some of these oldies have had to say. So I was at Stanford, their annual computer forum back in 2018, and Ed Feigenbaum gave like a review of a film that the Computer History Museum had made on AI. And in the process, he talked about what they got right and what they didn't. First decade of AI was focused more on heuristic search for problem solving, syntactic computational linguistics, and checker playing programs. Very preliminary kind of gaming kinds of programs. And then 65 to 90 was the knowledge-based systems, expert systems and such. So, like I said, when I was in IIT Madras, I was aware about this mycin and such things, right? CMU also had expert systems were being. And then, in order for the system to be able to act like a human, guess what? The system has to have enough knowledge about the real world. So that's where Doug Lernett and company came up with this thing called CYC, C-Y-C, which was trying to codify human knowledge about animate object, inanimate objects, and all this kind of stuff, right? What is a tree? What's a plant? And what's a human? And what's a dog? And what's a cat? And such. I mean, also linguistic stuff, right? And grammar and such have to be represented if you want to be able to deal with the sorts of things that Raj Reddy became famous for, which was speech understanding to begin with, and later robotics. So, in the first wave, handcrafted knowledge was put into the system by humans, decision support systems or expert systems with rules and such, right? And so they were reasonably good in perception, and in reasoning they were actually pretty good. But with respect to learning and abstraction, almost zero level of capability. Okay, and they were used for planning and cybersecurity and command post of the future and such applications. So they were these systems that were developed were narrowly focused on specific domains. Right? They were not general purpose to be able to apply across. I also said, let me take a look at the ICHCAI conference, which is the most famous, long-lasting conference devoted to AI, and it's international in scope rather than a country one. And so these were the kinds of sessions that they had back in 1969. By the way, this conference, at least once to my knowledge, has been held, and that was Hyderabad, around 2000 and something, late 2000s. It was held in the brand new Hyderabad Convention Center. And the inauguration actually took place in Triple IT Hyderabad. I was there with Raj Reddy and the chief minister and so on. So then I said, let's look at some of the different developments that have gone on. And this report that was produced by the OECD guys. And there you see even science fiction and such things being mentioned, okay? And later, of course, DARPA funds AI at MIT in 1963. And then, in 1970, there was this assertion by Marvin Minsky, in 3 to 8 years, we'll have a machine with the general knowledge of a human being. See, this is where the hype got out of hand. And then there was that winter because these systems didn't live up to that kind of hype. Then, of course, in the sort of early 80s, Japan had this 5th generation computer systems project, which everybody in the West thought was going to take over the whole world. And so that's why the MCC consortium was formed in Austin, Texas, where I happened to have graduated by the time that consortium got created, which was essentially a bunch of the Western computer companies. IBM wasn't part of it. DEC and CDC and UNIVAC, some of these names don't mean anything to the youngsters in this population, but in the end, it turned out Japan didn't actually deliver the goods on what they hoped would be this, leg up on the rest of the world that they would have through this focused way, government-focused way of orchestrating a lot of work. And by the way, similar stuff is now in the works in China, as we'll discuss later, okay? And then, of course, things like, in the case of IBM, Deep Blue defeats Garry Kasparov. By the way, 1997 is when I got my IBM fellowship. As I said, that's the highest technical position. At the table with me, with the CEO of IBM then, at the dinner where he got up and announced, the CEO announced my fellowship, was a guy who was the head, a Chinese gentleman from the Watson Research Center. He was the leader of the gang that was behind the system that was developed to defeat Garry Kasparov. Okay? And as a result of that, certain things happened. And later, of course, came the Jeopardy-winning work that resulted in the Watson technology. Okay? And as should be obvious from what I've said, knowledge is an important aspect. How you acquire that knowledge, where it comes from and such, have been the focus for a long time. So knowledge representation, for instance. Again, this kind of stuff is not focused on the way the deep learning algorithms work, okay? So some people, as a result, have thought it's all this magic thing that can do anything and so on. But as we said before, there are problems. So some of these slides are picked up from Raj Reddy's presentation he gave in Shanghai in November 2017. That's an important thing because it was soon after the Chinese government had decided, the Communist Party, once in 5 years Congress, where they decided they're going to go whole hog into AI, as I will discuss later. So how you get the knowledge, what kind of knowledge that's out there and all that, I'll let you read through some of these things at your leisure. But over the decades, these sorts of things happened in the first wave, if you like. And at this conference, all sorts of people from the government, from the Communist Party, from the Chinese Academy of Engineering and university professors and so on came and talked about the fact that they feel they have a leg up on the Western companies. Because the Chinese companies, the equivalents of Facebook, Twitter, Amazon, Google, have accumulated so much information about almost 1 billion people that is more applicable to similarly placed people in India, South America, and Africa than what the Western companies like Facebook have. The Western companies are mostly dealing with people who are richer and live in fancier homes and so on compared to the average Chinese person. So, of course, the Chinese companies are focused almost exclusively only on the Chinese market to begin with, by in many cases excluding the Western companies like Facebook and Google from doing business in China. So until they, of course, get beyond Chinese language and support these other regions' languages, whether it's Hindi or Tamil or whatever, Malayalam or Swahili and so on, they still have a hard road to cross. But they still feel that they can now give a run for the money for the Western countries as big entities, as well as specific companies in those countries. And so there's an excellent interview that was given by this Chi Lu, who started his career in IBM research in my lab, but then who became a bigger shot when he went to Yahoo and then to Microsoft, who for a period was the COO of Baidu, which until I attended this presentation, didn't know was into self-driving cars. And so they developed a whole operating system and they had a big ecosystem and all that. But soon after he gave this talk, because of some disagreement or whatever with its CEO, he quit. But still, whatever he has said, which is some of which is captured in that Wired magazine interview, is very revealing to talk about. And at the same event, Raj Reddy explained how, when he was doing the initial work, he thought certain problems won't be solved in his lifespan. But guess what? They got solved. And then he was trying to rationalize what led to the enablement of solutions to those problems. And that's where he talked about extraordinary compute power that became available with special purpose technology like GPUs and FPGAs and so on and so on, and more recently non-volatile memories, and also the innovations in the algorithms. He was basically referring to the born-again neural nets. By the way, deep learning by itself is not anything very new, as we will see later. For a while, I didn't even know what the heck it was, and I'd heard about neural nets decades before. And suddenly there was all this hoopla with deep learning. I thought it was something totally different. It's basically a relay. And he also said he didn't expect all this big data to come about. And so that was the third dimension to what led to these rapid progress that he didn't think will come about in his lifetime. And of course, AI is everywhere, and there is still the business of general AI versus AI for a specific purpose. So there's more of this about where knowledge comes from and how even things like crowdsourcing and gathering knowledge from by social media means and things like that, and the variety of data in terms of the modality through which it's captured, structured, unstructured, and in the case of unstructured, whether it's video or audio or still images and such, and also the emergence of IoT devices, on and on. These are the various means through which so much more data than the likes of Raj Reddy had imagined would happen. That's led to some of the revolutionary things. So here are some of the topics that are being talked about in HCI 2019 from 69, I think, right? 30 years is that, 69 to, so 50 years, right? There are still some same topics, and then there are others which are more expansions of a particular topic in a particular domain. So, of course, the conference has become like a zoo, tens of thousands of people attend, and so on. So, as far as the second wave is concerned, DARPA describes it this way: engineers create statistical models for specific problem domains and train them on big data. AI systems have nuanced classification and prediction capability, but they don't have any contextual capability or any, and they have only minimal reasoning ability. So if you look at the comparison between wave 1 and wave 2, you notice that with respect to reasoning, we have gone backwards. With respect to the other topics, there are improvements, of course, and that's where the problem is. And so things like Apple Siri and text analysis, as Google does all the time, and image recognition and AlphaGo and are the ones where this statistical based method, as opposed to handcrafted knowledge, has been made use of. And the enablers are the sorts of things that I already talked about, right? Compute power has gone up the wazoo, and also the cost of computing has come down dramatically, as you see in this bottom left corner. And the way they've looked at some of the topics that are the focus of the second wave was to look at the patents issued and what topics the patents were in. And they've been clustered in this fashion. So you notice NLP, cybersecurity, shopping, computer vision, medical applications, personal assistants like Siri and such, enterprise resource planning, all the focus, robotics, even MapReduce for that matter, right? So there is the Stanford research, the Stanford University has a research institute, research focused institute, let's call it, which is different from SRI. That's what I'm trying to do. They put out an annual report. So the latest report came out early this year, and it had some interesting high-level observations. And it's a very detailed report. I highly recommend you go look at this link and follow through. So they look at where investments are being made, where PhDs are being done, what topics, what do these people after their PhD do, and things like that. So, and also, geographic focus in terms of observations like China overtakes the US in AI journal citations, not conference citations. How the industry shift has continued. More and more of the PhDs coming out of these fancy universities are landing up not in academia, but actually industry. And of course, there is still a diversity challenge. 45% of the new US residential AI PhD graduates were white. Of course, there are lots of us non-whites out there, right? Indians and Chinese. But they are, in this particular instance, worrying about how many are African Americans or Hispanics relative to the whites, right? And of course, the dimension would be the gender orientation, right? Women versus men and so on. Turns out the likes of us who went from India or wherever to the US that then did PhDs in AI, they are staying back in the US just like some of us did, right? And so they give statistics on those sorts of things. Surveillance technologies are fast, cheap, and increasingly ubiquitous. And the topic of AI ethics, where are you doing the right thing? Are you training only on white people data and then trying to apply it to non-whites and seeing ridiculous things like a black man being recognized as a gorilla rather than as a human being and nonsense like that, right? It still lacks benchmarks. But a lot of people talk about these things. There are specific ways of doing comparisons and all that, just like you have the Transaction Processing Council benchmark in the database, things like that. As I pointed out before, even the US Congress has gotten the attention of, has given the attention to AI. This was that law that I read out. So neural nets have been around since the 50s, nothing new, okay? What does it do? You feed in, let's say, a picture of a cat. The first layer might recognize what's dark and what's light. The next layer detects edges. The next layer detects a combination of edges, which can lead to the identification of features like something is an eye, something is an ear, and so on, right? And then ultimately, by combining these features, you come to a conclusion like, is this a cat or a dog or something else? But it's still mumbo jumbo, this whole layering and what happens through all that. And if this particular picture is said to be not a cat, this thing cannot come back and say why it concluded it's not a cat. It cannot say, oh, these are the features that were missing or that look different from a traditional cat. Okay? Another way of looking at this is also to talk about, when you input some handwritten characters, what do these different layers do? Do they do only purely local examination of the different parts of that picture that's being input? Or do they do some global kind of comparison of information? So the picture map performs a local analysis over the whole input space in the initial state. And then the fully connected layers perform global analysis to come up with a conclusion. Is this a 2 or is it a 3, where some portion of the 3 is missing, for instance. And this kind of stuff has been worked on for a long time. In my own project, there was this Desi woman who was part of it, Tanveer Saeeda Mahmood. She got a PhD at MIT on image processing. So they used to work on things like recognizing the zip code for the US service, or since that particular location used to do this manufacturing, even identifying visually faults in the manufacturing of specific display, things like that. Okay. So while that's the neural way of doing things, the bottom part is the old way, the symbolic way of representing what an apple is, right? Describe it as a fruit that grows on a tree, and normally it will be this sized or this colored and things like that, right? So this is a very detailed way. So when the speech understanding work was going on at CMU in the mid-70s, guess what? They used the syntax and semantics of the language and even the phonetics. They measured the frequencies of the different parts of speech that were spoken in order to even do disambiguations and things like that. If, let's say, what's the car and the animal? Jaguar is mentioned, you can look at the rest of the sentence to disambiguate whether this particular reference to Jaguar is to the animal or to the car. Things of that nature can be done in a much more explainable way. So it turns out this deep learning work in the case of ImageNet classification, the errors by the system became less than the human errors around 2015. Okay, so in that narrow domain, it does a good job. So narrow AI is of that nature, right? Where you have large amounts of data and it's able to do superhuman level of inferencing and so on. But if you look at broad AI, where you don't have as much data to train the algorithms in, and also it has to be multi-domain and multimodal and multitask, you have to involve distributed AI technologies. And that is highly important in the enterprise kind of context, or the different kinds of organizations. Don't interpret the word enterprise to mean only the Mohan kind of Wall Street or the CIO type of people are interested. Even in the context of B2B or people to government kind of context, NGOs, even such things, will have situations more commonly where there's very little data. And so those situations also, because you are doing something more interesting than the dumb thing of concluding whether something is a cat or not a cat, where, if you make a mistake, you're not going to be taken to the court. Whereas in these other contexts, you will be taken to the court and your liability things and all that will be there. You need to do a far better job of explaining why you concluded something. And then, of course, comes even more general purpose AI, which is general AI or artificial general intelligence, where you want to actually combine the neuro and the symbolic AI technologies to do a far better job and have seamless cross-domain. What you learned in one domain, being able to adapt it to apply to other domains. So this kinds of narrow AI work has been put into production usage, if you like, in the case of language translation, speech transcription, language processing in general, and also visual recognition. So there are some of these sorts of use case scenarios that one can talk about, how to even recognize entities and relationship between entities and such, recognizing parts of speech and doing live translation, even as the US soldiers were wandering around in Iraq, talking to a common man on the street in English, and the translated version is heard by the other person. And then when the person speaks back in Arabic, that gets translated to English. That are moving objects and tracking players in games and such things. But it's full of problems still, because you can fake the system into coming up with wrong conclusions. You take the image of panda, modify a few bits here and there, which are not visually recognizable as the messed up version of the panda original picture, And then the system concludes it's a given. And it's very confident too, 99.3%. And then there was this famous case where this internet trolls were able to make this AI bot say that Hitler was not a bad guy, and things like that, right? And then this other one where this kid holding a toothbrush is concluded as a young boy holding a baseball bat. So there are more of these sorts of things that are out there. If you want to look at the Gartner kind of, the famous 4-quadrant, how many of you know about Gartner and 4 quadrants pictures that they have for class? Not anybody. Wow. Okay. They look at any kind of technology and they are trying to figure out who is a leader and who is a follower and all that, right? So along the X dimension is the completeness of the vision, from the left side being not so complete to the right side being really, really outstanding. And then in the Y-axis, it's the level of execution, the ability to execute the vision. So ideally, you want to be in the top right corner. Okay, that's the best of both worlds. Your vision is great, and you're also able to realize your vision. So they did this recently. This was in January 2021, and interestingly enough, IBM is sitting up there. But if you look at Google, their vision is slightly better than IBM, but their ability to execute is lower, and so on and so on. I'll let you go look at this offline. One of the problems that people face in the AI domain, especially for a few university-based people, will be the fact that you don't have access to real data. Okay, so and also a lot of times in the good old days, you won't even have access to the software that's out there that you don't have to do yourself, because it was all sold for money and you didn't have enough money in the universities to pay for it or whatever. So these days, of course, there are lots of open source kinds of systems that have been developed by even commercial organizations that have been made it available to the rest of the world. So here are a bunch of these open source AI libraries and frameworks. It also is the case that there are some pre-trained models that are available in some specific domains like computer vision, NLP, and such. So do make use of these things. Of course, the popularity of some of these sorts of things depends on who put out something, right? IBM puts out system ML, people are yawning. Whereas something with less capability is put out by Google, TensorFlow, suddenly all hell breaks loose. Everybody and his uncle wants to listen to Jeff Dean talk about it, and they want to proudly say they are using it and put an entry in their LinkedIn profile just so that they think that they are as cool as their neighbor and so on. So some of this also needs to be taken with a grain of salt, whether it's as good as the numbers would make you believe, how many committers are there or how many people are using it. So I feel bad at times when even in our own building, one end of the building is working on system ML and another part of the buildings people are using proudly TensorFlow rather than this other one, system ML, which has been open sourced and the name has been changed recently to system DS or something. So be cognizant of that too, okay? There are all these global partnerships on AI and such that have been defined or created in Europe. You can go look at the details. Various countries over the last few years have come out with national strategies on AI. And even at the European Union level, they have strategies in addition to individual countries within Europe having that. In France also, as you probably know, they've put out a strategy back in 2018. And China in particular, as I said earlier, in 2017, at the end of their last CPC, Communist Party of China, once in 5 years event, came out with these sorts of statements. They have extremely specific goals. And China decides on something, they just march like crazy. I mean, no ifs and buts, and some people are going on strike and the land cannot be acquired. Forget it. The government says, and everybody says, okay, yes, sir, and does stuff. So it's along those lines that they've got these major plans, and I welcome you to go look at this document, which is the English version of the Chinese document that was produced by this entity called New America. Okay, and they also pass some judgment on whether they think China can deliver the goods. Of course, China has had its share of problems. You probably read about some big deal Chinese company that was in the real estate business going kaput and things like that recently. But still, there's quite a bit of focus there, and they really think that they have now a chance to one up, and hence all this current, even after the administration change in the US, there is still lots of not so pleasant relationship between China and the US government now, because of course, many people in the US would like to believe as if it's their birthright to be the leaders ever in high tech, which in my opinion is a bogus claim, and they shouldn't think that way. You better work at it and don't just declare that you forever should be the leader just because you think so. That you better do the necessary things in order to maintain the status, not just do some silly thing. Suddenly, capitalism, which said survival of the fittest, now that is forgotten and walls are erected and things like that. So I'm not buying into some of these measures that are taken in not so nice way to Huawei, for instance, or badly treated, things like that. So anyway, there's a lot more here one can talk about. Europe, you'll notice, if you look at the strategies of the different parts of the world, based on their own history and also natural resources and the kind of trade that they are engaged in, that they are good at, and so on, the focus areas will be different. Okay, so Europe, for instance, for the longest time has been focused on privacy much more than the US has been, transporter data flow restrictions and so on. So they talk about ethics by design and security by design as one of the major driving principles. And they're also talking about European AI research excellence centers and things like that. And they talk about world reference testing facilities. And they also want to have a digital single market, just like the European Union was originally created more for physical goods. So they also talk about, the three pillars of European AI strategy, increasing public-private investment, preparing for socio-economic changes, and also having an appropriate ethical and legal frameworks. There are a lot more details. Of course, India, for its part, also put out a strategy document in 2018. And more recently, it even put out the responsible AI document. IBM actually took some leadership in this space some years ago by putting out what it means to be responsible in developing and deploying AI technologies. And to what extent the Indian story has actually been realized, I don't have full understanding of. If you have a better understanding, let me know. But the sectoral focus, again, given India's sizable population being engaged in agriculture, that's one of the topics, and then health and education. Leveraging AI for education has been a big deal. So there was actually an interesting conference that Modi inaugurated last year, I believe, which went into some of these sorts of things. It was actually very good. They managed to round up from different parts of the world. Meanwhile, Chris Gopalakrishnan, who happens to have graduated at the same time as I did from IIT Madras, MSc Physics, and then later he did computer science. He has funded this work, Itihasa, to document the work that's gone on in India in AI/machine learning. There's another document which is on brain-related research. He has funded work both at IISc and IIT Madras from his personal funds. And then there is all this stuff about how you and I might get excited about the specific AI algorithms, developing model and so on. Guess what? Bulk of the work is actually before you get to that point. Prepping the data. The boring thing is actually the most important thing. Otherwise, it's garbage in, garbage out. So NASSCOM has concluded it's $1 billion money-making opportunity. And so that's the bottom report. Tamil Nadu might have missed the reference. I'm an honorary advisor to the Tamil Nadu e-governance agency. They put out that document, the rightmost one, which is on safe and ethical AI policy. And in fact, the day after I landed, I came in on 10th of December. There was an all-day event in Chennai, which the Minister for IT also took part in. And that was focused on AI, the AI conclave organized by TNEG. So Tamil Nadu is being very aggressive in this AI space as well as blockchain. So here are some of the interesting places and so on. So Ravindran, Ravi as we call him, he was one of the keynote speakers at that 10th of December event that I just mentioned. So the Robert Bosch Center for Data Science and AI is doing a lot of good work. My own IIT classmate used to run Vadvani Institute for AI, P. Anandan. He retired and now another guy is taken over. And they are in the space of AI for social good and so on. So there's more of this. And as I said, there was this conference, virtual summit, Responsible AI for Social Empowerment that was done in October last year that Modi inaugurated. And you should go look at some of that. There was even there are, of course, now newer research labs. Google started the research lab, which is focused on AI in Bangalore. Manish Gupta, who used to run the IBM India Research Lab, is the head of this one. And of course, IBM has been working on AI-related topics in India, and so has Microsoft. Some of these things I'll skip. Singapore, as you can imagine, Singapore being one of the most important ports in the world, is focused in terms of application areas on port-related things, intelligent freight planning and things like that as the application area. And they are all National University of Singapore, where I spent 6 months, and the Singapore government are also doing a number of things together. US government has many programs, both the White House and the individual federal agencies. I won't go into the details. DARPA, as usual, is pumping a lot of money into doing various things, train an AI-ready workforce, promote an international environment supportive of American AI innovation. This is where I have my own questions about why suddenly this narrower focus than the old days, telling the rest of the world, let American companies come in. Capitalism is good, and let's increase the size of the pie and this and that, right? There are also these sorts of specific strategies that they have got, make long-term investments in AI research, ensure the safety and security of AI systems, expand public-private partnerships, better understand national AI R&D workforce needs, and things like that, right? And the NSF, the National Science Foundation, which for the second time is now being led by an Indian, Panchanathan, Panch, they call him. First guy was my own IIT classmate, Subra Suresh, who is now the NTU president in Singapore. They've got these sorts of efforts underway, starting more narrowly focused AI institutes with a particular university as the lead university, and the names are listed there. The Office of Management and Budget has a bunch of things. I want to talk about this conference that was held. Please, when you are looking around what to focus on and all that, do pay attention to some events like this. This is the Bosch guys in Germany who had this AI con, they called it, earlier this year. I, by chance, noticed it and I said, okay, I'm going to sign on. Free and virtual and all that, right? So I didn't even know they're focused on self-driving cars, okay? I had even given a talk in Bosch in Bangalore way back in January 2009 as I was going back to the US after my India assignment. but I didn't know that they were specifically working recently on this kind of stuff. And so they talked about, now the CEO of Bosch and the CTO talking about what it takes to do some of this kind of work. And then they said, you can't test all possible scenarios in the factory because it's hard to create some of these unusual events. So instead of trying to do everything in-house, let's instrument the cars, get the information back to the factory, and combine the real-world experience of people, even in the non-self-driving scenarios, to get more information, more data. Talk about data not being that big in many environments, and this is another example where in the factory, you can't also spend too much money and resources because you have to justify those things not based on advertising revenue, but actual revenue on the cars and such, right? So that's why they said it's important to combine information from different places. And they also said you need to combine not just information that's fed into a model and the statistics based, but also codify physics-related things like laws of the land and so on. You should explicitly incorporate in the model, not make it learn. That is, how do you figure out in this road that's in front of this building what the speed limit is? You don't analyze over a long period of time tons of data to magically infer what the speed limit is. Damn it, it's a fixed number, just shove it in. So it's those sorts of things, right? So they talk about, as a result, physics-based models versus data-driven models. And each has its role to play, okay? Causality and all that, E equals MC squared and such, when they apply, use it. Don't try to infer that thing. It will take way too much effort and you will make mistakes and so on. It's generalizable, it's explainable and such. Whereas the other one, black box, gray box, whatever non-physical domains, limited statistical guarantees, generalization difficult, right? So there are more examples of how to combine the two. There are different ways of combining the physics-based models versus the data-driven models. And so you will see there are specific scenarios, and I even more recently heard about some of this in another presentation that was given a few days ago, where a guy from IIT Tirupati was speaking about driving on Indian roads. It's so much more difficult, locating potholes and so on. And even in the context of trying to find a nearby car, radar doesn't always work. LiDAR is even more expensive. Whereas in those situations, visually trying to recognize what's close by is a better way. So this is now combining physics-based model versus and a numerical-based model. So it's things like that. And they also talk about Bosch AI, a combination of AI plus IoT. Okay, I don't have the time, and you're probably getting nervous in terms of what's the time? I don't even know what the current time is. Yeah, sorry. Okay, so I'm already past the 1 hour slot that I was given, right? It's okay. Okay, so the third wave, the contextual adaptation one, is the one where systems construct contextual explanatory models for classes of real-world phenomena. The goal of it, as you can see in that notional intelligence scale, to improve on all fronts: perception, learning, abstraction, and reasoning. And so here, AI systems learn and reason as they encounter new tasks and situations, natural communication among machines and people. So the notion of man-machine interaction is something you do need to take into account and not completely rely on the black box approach as in the second wave. So this is talking more about how DARPA over the decades has invested a lot in various projects and how some of the projects outcomes, research projects outcomes, have actually been translated to practice. So the red things there are DoD transition, and the green ones are direct commercial impact. Department of Defense is what DoD is. Some of you know. And so, as you can, if you read the tables at your leisure, you will find out that lots of interesting things have been done by the initiatives that DARPA put in place. Robust automatic transcription of speech, deep learning, broad operational language translation, global autonomous language exploitation, MX, deep exploration and filtering of text. These are very specific initiatives, just like NSF has calls for proposals. I guess in India, it's DST that does a lot of these. So the path to broad AI involves being able to explain why certain recommendations were given, whether it's accepting the insurance claim or rejecting it, or credit card application, how you don't want these systems to be easily tweakable to come to wrong conclusion. In that one, the stop sign with a few bits modified is actually interpreted by the system as a 15 miles per hour speed limit, which means a car won't stop, and that can cause accidents. Right? Ethics, where you better make sure that whatever you are doing is ethical by various definitions of what it means to be ethical, not unfair to minorities and things like that. In India, that would translate to OBC, is that right? Scheduled castes and so on. People not being treated badly just because you train non-such people's data. Learning from small amounts of data and also transfer learning from one domain to another. Reasoning, physics of AI, which means developing even special purpose technologies. I won't get into this, but federated learning has to do with privacy preserving ways of sharing information across different organizations and still combining the information and coming to some conclusions. Certainly, information might be for a specific kind of people, and you want to make your thing be more general than that. And so, but at the same time, each of these organizations, from where you have the data, they might have reasons not wanting to share their data in the unencrypted form. So how do you have the cake and eat it too, essentially? Turns out even making your algorithm run on different kinds of hardware and operating systems is a thankless job and a lot of pain involved. So there is this thing called Apache TVM. If you code to that one's APIs, it will do the translation. It's like coding in a high-level language, and then the compilers for different hardware and operating systems doing the work of translating it to various computer architectures and operating systems environments without you yourself having to worry about it. Similar notion for now being able to take your ML models and develop them once and run on platforms. The compute demands, as I said at the beginning, are going up the sky. They are far worse than what we had been able to handle in the past with the Moore's law kind of doubling of compute capacity every 18 months. This is now saying, at least for the specific workloads, it's not a general statement, that you have to keep in mind. How applicable these particular benchmarks are for which this kind of number is generated is questionable to the general population's needs for AI and such. But if you go by the specific benchmarks that are mentioned there, AlphaGo 0, the neural machine translation, and VGG, and ResNet, and so on, the AI need is doubling every 3.5 months. This is crazy. And here we are talking about Moore's law coming to an end. At the same time, there's this kind of resource requirement increase going on. So it's unsustainable without significant hardware and software innovation. So what are some of the innovations being done? Turns out for a lot of these statistics-based models, accuracy is not so important, meaning double precision. And so people are now talking about reducing precision while still getting reasonable results, and thereby getting more compute power being applied. And also even combining digital cores with analog cores, and also having special purpose material that lets you do some things interestingly. So IBM turned a pre-competitive consortium that was there in Albany, New York, which was working on chip technologies in general in the past, to focus on AI hardware. Okay. So what are they doing? They are hoping that by employing the things that I just mentioned, you can keep this thing going, right? It's a logarithmic scale on the y-axis, and specific things that are being done are 8-bit and then even 4-bit and things like that, right? Precision instead of 32-bit or even 64-bit precision. The other thing that's being done is, I mentioned very briefly, non-volatile memories. These are byte-addressable non-volatile memories. There are various technologies for that, phase change memory being one of them. IBM worked a great deal on that stuff. I used to go around giving talks on what are the database implications of byte-addressable non-volatile memory. And there are other people now doing PhD theses on such things, where because the material actually gets heated and physically undergoes a state transition, writes take a longer time than reads. There's extra circuitry in the memory itself in order to do these phase transitions. So what these guys are now talking about is, since there is a bit of this extra circuitry there, push into the memory itself certain aggregation kind of operations. Instead of dragging the data into the ALU and such, and doing the computation there, which means that you are now restricted by the bandwidth of the memory hierarchy and the compute capability of the cores. You can now move some of the computation and do it in parallel in the memory itself where the data is. So instead of data moving to the compute element, computational work is moved into the place where the data is. So AI for the enterprise as a result requires a lot more things to be done, from core AI to trusted AI to scalable AI. I always have a problem with this word. Operationalizing AI at scale requires employing AI even in the innards of these systems. Even data prep, can you make use of AI technologies to make the data prep go better? This is like data cleansing, all that used to be worked on in heterogeneous data integration in traditional databases. In this context, where we are today on the left from where we want to be on the right requires various things to be done across the whole stack, top to bottom, okay? From the application level to the algorithms level to the compute level to the data. And some of this has to do with, are you training with static data, or can the data dynamically change the trained models and such on the fly instead of bringing everything to our knowledge? This is also similar in flavor to, in traditional database query processing, you have a cost model, which I said was based on my first manager's work, for which she got a lot of glory across the globe, which was based on very simple-minded ways of modeling I/O and CPU and so on. Over the decades, those things have been made more and more sophisticated. When you move the database system from one kind of hardware to another, whether it's a CPU or disk or whatever, communication hardware, you have to go plug in the new numbers that relate to the new environment, or can the system, after running a bit, self-monitor and adapt its parameters and so on. It's similar in flavor to that as to what you can do here. Trusted AI involves fairness, explainability, adversarial robustness. That's the one where modifying a few bits made the system think a panda is given and such, right? Or the stop sign being interpreted as a 15 miles per hour sign. And then transparency, is it accountable and so on. In the case of data automation, using AI to get your data ready for AI, AI-assisted data discovery, data quality, data synthesis, data labeling also for training models and such, how to automate the deployment and operations. One of the interesting projects that came after the Watson Jeopardy competition where the system defeated the two best humans in a very simple question answering scenario where the system didn't even have live access to the internet is this one, where the system was asked to engage in speech and debate competition, where the system at the beginning can be told, take the pro position or the counter position. The proposition might be Mohan is a good guy. The system can be told to support that or to say, no, he's a bad guy. Now, what does it have to do? Here, it has live access to the internet. It has to formulate its arguments in a human-like form. It shouldn't look like it's synthetic. I mean, it should be so good, the Turing test fail, right? Or pass, I guess. Is the right way of saying. So modeling of human dilemmas and forming principled arguments, listening comprehension, rebuttal. So it not only has to come up with some statement to say that Mohan is a good guy, but when Jagdish says, here are the reasons why Mohan is a bad guy, it should now come up with counter arguments. So it has to understand what the heck he said and comprehend his point, what sources he relied on that he quoted, and then maybe go and say, hey, those sources are untrustworthy, they are fake sources and such. Data-driven speech writing and delivery. So you have to actually deliver the speech in a human-like form. Push us frontiers of AI so we can build well-informed arguments and make better decisions. And in the process of doing all this, some of the work, by the way, was, since we talked about HIFA, the leadership for this project was actually based on IBM's HIFA research lab. There were other parts of IBM research working on it, but the primary leadership was in HIFA. So they open source 12 new of the APIs that they developed in this context. There's a very interesting article that goes into the architecture of the system that was published in Nature. And so the whole scheme involves, I mean, the format, if you like, of the debate is opening speech by the system and the human, then the second speech, and then the summary speech and the summary speech. So it's in the second speech and the summary, you have to refer to the other person's arguments and counter arguments and all that. So it's a pretty interesting set of stuff, and lots of NLP and all that will be involved because the human is not going to talk like a, grammatically perfect person and such. So you have to account for such things also, even though the system might be trying to be, grammatically correct and everything. The guy is not going to be, or the girl is not going to be. In this case, it turned out, unlike in the case of Jeopardy, the system didn't win. It came close, but didn't win. Okay, that's important to keep in mind. So AI for data management basically involves, instead of hardwiring a lot of things into the database system, as to when to reorganize the database, when to take backups, when to modify the cost model, and even the assumptions made behind the development of the query plans. If they don't turn out to be true, dynamically re-optimizing the query and such, and all the sorts of things. So in summary, a lot of advancements have happened in a short period of time, in the recent past, but there's a lot more to be done. And for it to really apply in broader context than cooked up benchmarks and such, or algorithms being tested using synthetic data, we would really like people to work on using real-world data. And this is where, as part of this RAISE conference last year, I think, is when the Indian government decided to openly make available GIS data, right? So some of those sorts of data sources are out there. I didn't list them here, but there are various places where you can get some open.gov is another one. By the way, I mean, my area is where this whole thing of making government data publicly available started. This was the mayor of San Francisco who originally did this initiative, came up with this initiative, who is now the governor of California. Okay, Newsom is the this, and now lots of governments across the globe are doing this. But the problem is, as Ravindran said in the conference on the 10th of December, a lot of this data, while it's available, it's all a mishmash. They are not specific formats, and the different organizational units of the government might put it out in different form. CSV versus XML versus something else, JSON and such things, right? So that's something to worry about. How much metadata comes with the data? This is all the problem with so-called data lakes. Just garbage collected without enough associated data, so you don't know what you can trust. What are the rules associated with the collected data in terms of what guarantees you gave to the people who parted with the highly sensitive data, that you didn't bother to then attach to this data, and hence you cannot be expected to, or you would not be actually adhering to the understanding that people had when they parted with valuable data, that you use it properly and not illegally use it and so on. I keep revising these sorts of talks and so on, so if you want to keep tabs on my activities, I regularly post everything on the web and things like that. So thank you so much. Sorry for taking that.
Thank you, Mohan, for an overall view on artificial intelligence, national regulations, way forward. Open for the discussion, please.
Man.
That was a very interesting overview of the past, present, and the future. So I just have two questions. One is, in the context, what do you see as the polygon solution which can help? What could be some of the potential?
Yeah, in fact, that event that I mentioned on 10th of December got into some of those sorts of discussions. So I highly welcome you are going and looking at the different presentations given, in particular, the one that was given by Balram and Ravindran. And of course, you can also go to the website of the Bosch Center in IIT Madras. So they talk about number of things in the healthcare space, in agriculture. See, some of these sorts of things have been worked on long ago also. In fact, interestingly enough, in Hyderabad, there used to be this Bairaju Foundation by the the family foundation of the famous company, Satyam Computers, which was doing very good work. Of course, Satyam, the company, then got into deep doo bad things that they did. But they were trying to do things like remotely assisting the farmer that found some problem with the crop because some insect or whatever had some damage, and then they were going to show through, in those days, picture taken or even a live connection through a video hookup, so that the people sitting in the central location be expected to go all over the place, just to physically be there to do the work. And so some of these sorts of things are also the focus of the Wadhwani Center for AI. So anywhere where you have problems that can be helped by getting some real numbers as opposed to imagined numbers, that can improve the quality of life or service, can be the areas where you focus. And of course, as is the case with more commercial kind of environments, you need to, in the commercial environments, explain to the C-suite guys, this CFO, CEO, and so on, what would be the return on the investment. In a lot of those cases, you might not be able to quantify the results. And so that's where, doing a prototype implementation and having some trials and such can then give you the ability to demonstrate, not in the production usage way, but in a limited deployment way, what is feasible and how much of an improvement it could make. So one of the things that was done in the Tamil Nadu E-Governance Agency was this mundane thing of taking the class attendance. So what they did was to come up with the face recognition way of recording the attendance. The students just walk past. They don't stand there and stare and all that. Can you now use that as a way of reducing the wasted time in the classroom at the beginning, where the teacher will call out one by one the students' names and so on. So there are things like that that can actually improve the situation where the more mundane way of doing things reduces the amount of time you can focus on real task at hand, which in this case would be educating the students and such. And then at the RACE conference also, there were various presentations, and I believe even the RACE conference videos are available online since the whole event was virtual. And by the way, Raj Reddy was one of the keynote speakers sitting along with Modi and all that. So, and even in the context of voting and such, or validating these claims that are made for LPG, what do they call it? The rebate or whatever that's. The good old days, it used to be eaten up mostly by the middlemen. Yeah. So they're now using this way of directly sending it to the end person rather than letting some intermediaries gobble up a lot of money. But the healthcare arena is another one where even a professor from Berkeley used to work on. He's the guy who came up with the Inktomi search engine before even Google became a big deal. Yeah. So he's now at Google. So he used to be involved in a project that involved the TNET group, Junjunwala's group in IIT Madras, where they were trying to do detection of eye problems through telepresence. So there are many, many such things where we could improve the situation. Our port operations, there's heavy backlog these days during COVID time. Even the Los Angeles port and such, there are like 45 ships or something out there in the ocean waiting to get a slot in the harbor to anchor the ship and unload and all that. So any place where technology can help with improving productivity or usage and such, increase the occupancy rates and such, is amenable to these sorts of solutions. And we have enough of these sorts of things being done inefficiently in India that it's merely a question of who has the money and the attitude. So even the Tamil Nadu government, for example, I was there just a few days ago, they were saying they have to first educate the different departments. See, the TNEGA has its own, experts and so on, right? But they can only do the backbone in the case of, for instance, blockchain arena. They want the apps themselves that leverage the blockchain backbone to come from the forest department or some other department and so on, so the transportation department. So you need to now go tell them what the possibilities are. And also, ultimately, all this has to be done through tender process and such, right? If you're going to do the coding by using outside entities, then there is additional work to be done to convince enough of the players out there to apply and make things become real. Any other? Yeah.
My second question was about computerization.
Yeah.
When I think about this computerization, digitization happened, there was a apprehension of job loss. Do you foresee something like that, say when AI technology is more widely adopted, and what are possible difficult adoption?
See, I had that one of the points in the very initial slide on potential problems. So that is definitely something that needs to be worried about. So, of course, in the US and most manufacturing in the country, cheaper locations, Southeast Asia, and such. So that's partly worrying, I would say, from America, who relied on some sort of job, didn't want to get retrained, skills enhancement and all that. talks about clean food and things like that. So we do need to worry about that, but the hope is that provided, I mean, given the benefit that India has, which China doesn't have, it's the youth population of India being such a high fraction, hopefully at the lower levels, meaning the younger levels, you could make them become the resources that this area demands. In fact, if you look at that Stanford report, it will talk about some of these sorts of things, right? The requirements that are out there for data science trained kind of people. And that's why, by the way, Berkeley actually initiated a course a few years ago that can be taken by any undergrad, any major person. And that involved a bunch of people that came from even sociology kind of departments and art department and so on, the committee that then designed this course. So the problem might be with some of the people that are doing more mundane work that could be automated. And so there you need to carefully look at it. I mean, I don't think there's going to be any, wave the wand and you'll have your cake and eat it kind of solutions. But I think more of the impact will be on people doing technical work. Less will be, because India has already become like, especially South India, in the automotive sector, lots of work going on, right? With so many foreign companies, I'm sure, especially near Chennai and such places. So in that sense, some of the mundane assembly line kind of jobs, even without necessarily the full-blown deployment of AI technologies, I don't know to what extent these, I haven't been to any of these factories from there and so on. How automated they are, I don't know, but I'm presuming that they are fairly automated, but maybe there's scope for even more automation there by deploying even more sophisticated robots and so on. So I don't know whether the impact will be as severe as people have imagined over the decades about AI and job loss in our context compared to the Western countries. Could be wrong about this, but that's something where sometimes the press people and the politicians mumble some nonsense and try to get away with it and try to get some kind of viewpoint established out there that might be completely wrong or not based on real facts. So that's something that people have to worry about, of course, the politicians and so on. So that Tamil Nadu governance guys are thinking about that. They had a lot of press people at that event on the 10th, when the minister also was there, the IT secretary was there, and so on. So, other questions, comments? I'll keep talking, otherwise. No?
Thank you for the talk. This woman computer debate that we have in the link.
I would suggest to go and see. It might be there. I doubt very much it was done openly, as far as I remember. The woman that led the effort from IFA, she came to my lab and gave a presentation. That was, I believe, after that debate. My recollection from that is that I wasn't there, I didn't watch it, right? My recollection is that that thing is probably. But definitely the article will talk about it, the Nature article for which I put the name. I believe all of these have given our sources from which without having some special rights you can download and stuff. You were.
So we have all kinds of government that we have to take note that we are concerned about the state and they seem to be concerned about Facebook kind of organizations that not well. And then in China, it's all powerful development that they have there. But they are building AI also fast. So when we say some doctor government factor comes not is interested in the beginning is private how feasible is it? Because it's an international, right?
Yeah. So let me, the others say what you're saying. What you were saying was that there are different approaches being taken by the different countries or regions, like the US versus Europe versus China, where in the case of China, as I said, they are not so bothered about privacy and such. Everywhere you go in China, the camera is tracking everything. But then I was so surprised to find out in some recent post somewhere, Instagram or somewhere, that Chennai has the worst, densest number of video cameras that are doing surveillance. I was like, I thought after 9/11, America was the one where every street corner there is on top of, if you have a light, street light, I mean, what do you call it, traffic light, that they all have on top of them cameras. But I had no idea that even in places like Chennai, they have now got so many cameras that are tracking what's going on and such. So anyway, so her question was, how can, when so many things are already at play, that some newbie effort at trying to deploy AI, like let's say Tamil Nadu e-governance agency and such, at this point begin to talk about ethics and fair use of AI and so on. Is it possible? So the point is, in some ways, it's like how with 3G and such, we were slow in getting on to cell phone technology, right? Or another way of saying it is, we were not so good in connected technologies. We were slow in having even home phones and all that. My dad had to wait for 8 years to get a home phone connection, right? So then you talk about how leapfrog the rest of the world by adopting new technologies faster than the other guys. And I saw this in Bangalore when I was based there, because the same IBM Global Business Services people that were servicing the likes of Verizon, AT&T and such, Sprint, were also servicing Airtel and Vodafone and such. There were so many problems they were having in making these long established guys switch over to modern ways of doing things, because there were so many vested interests and this and that. People who were kings of their hill didn't want to give up control by switching to something where they might not know a thing. And also there was all this issue of upward compatibility and this and that, and having to justify to the C-suite guys why you should rock the boat and such, right? And what would be the extra benefits that will come from it, new customers or more satisfied existing customers and so on. Whereas these guys, Airtel and such, they said, what the heck, we are starting from scratch, we don't have any history to deal with, let's go with the best of the best that's out there. So in that sense, if you didn't have something already that constrains you, you can be actually, from the beginning, do stuff in a more methodical way than doing this patch over patch of taking some age-old stuff and trying to make it, what do they call it, training a dog new tricks out of it, right? Rather than getting a new dog which already knows a lot of the tricks. I don't know if the analogy works, but you get the point. Any other comments? Tell me if I'm wrong about some of the statements I'm making. I like, debate.
Another question.
Yeah.
In this artificial intelligence, machine learning, deep learning, boom, how much neurons in the brain or brain we not already, how much
Well, the point that has always been made, even when this manufacturing and all that moved out of America, was that don't get worried we should just move up the stack and do more intellectually demanding work than the mundane, very physical kind of work that was involved in digging for coal or putting components together to get a car manufactured. So if you think that way, as long as there is something interesting to do, it's not like you're losing for good your neurons or they're just vegetating and they're not doing anything. In some ways, I said I'm retiring from IBM. I'm not going to just sit there and twiddle my thumb. I'm still going to be active in the community. So it's somewhat like that, right? So I think along those lines, actually, one of the projects going on in Almaden, led by another Indian, Dharmendra Moda, Savayati, Bombay, is what used to be called the Synapse Project, which is actually doing the brain modeling, which got lots of publicity, similar to the European Big Brain Project, right? So which is trying to build systems that behave like the human brain. And so they even developed a special purpose chip, which has the following property. It's very good in doing some simple-minded stuff. Very good in the sense of resource consumption, energy usage is very little. Apparently, one of the big things about the brain is that it uses very little energy. It has so many of these neurons and these synapses and their connections that it's good at doing something like systolic computations. So what these guys were doing in the Synapse project was trying to see, can this chip be used for some specific kind of applications where its power requirement and all that is a lot less than a normal general purpose CPU, which is still different from the the chips from England that are used for IoT devices. Something. Yeah. I'm still not getting it because of you. Yeah, right, sorry. So those are already sort of, if you like, triple chips, but the particular one that was done in this project by Dharmendra and company is even more simple-minded. And he gives some analogy, I've forgotten now, a bottle of water or so is the energy that the brain uses. So translate a bottle of water as energy. So I don't think it's like we won't have anything more to do, because as has been mentioned, even the data prep is a non-trivial thing at this point. And so innovating on the algorithms level will still go on. There is enough scope for more interesting work to be still done. Even if the guys who did the getting Colloquium and such people think that deep learning will solve all the world's problems, which I would consider to be high. There is still lots of work to be done, at least in the lifespan of everybody, I would say, in this room. So that's not something to worry about. But as I said before, in the case of the US, there are some of these people who are jobless or whatever because they chose to not want to move, didn't want to retrain, and they took for granted certain things. So if some people in India are going to rely on subsidies and this and that and don't want to change their way of working, where they live, what they work on, then that potentially could be a problem. But the problems I've heard in Kanchipuram and such places is that the weavers have left their traditional weaving business because these factory guys come and work in an air-conditioned environment. Will take care of your transport, even pick you up in the morning, drop you back, and your kids can go to schools that are much better than these village schools, and arrange for all that. So the traditional crafts business has been affected. So whether you think of that as a major loss or not is now a more philosophical question. My wife, who's writing a book on the sari, got into all this discussion because she was wanting to go find out how to have the cake and eat it too, and hence the promotion of all these handicrafts and so on. Don't go for synthetic clothing, go for handicraft things. I went with her to some of these places where people are working in really bad circumstances, whereas in Pollachi, Ethica's brand, they've got more like a factory-like setup for the women to work in. They even stick the picture of the master weaver in every sari or whatever that they sell, so that they get more, mental satisfaction. Also, not the middle guys being thought of as if they are the creators of these pieces of art, if you like. So there are things like that that the politicians again can do in order to change the lives of the people who do a lot of the work but don't get enough of the monetary benefit as well as even the psychological benefits of having produced something, because the store guys wind up getting all the nullies and the other guys who are at the order, not the actual people doing the artwork and such. So, yeah, thank you.
Just a couple of formalities. I request Dr. Santakumar Mohan to honor our speaker with the Institute Memento, please.
Thank you. We saw a website page where this was all explained in great detail. What is behind this logo? My goodness, I was quite impressed at the effort that went.
And last part is vote of thanks. I request Reno to say.
Good afternoon, everyone. On behalf of the Institute Fraternity, I would like to extend a heartfelt gratitude to Dr. C. Mohan for accepting our invitation to deliver a talk as part of the Institute Colloquium series. We're especially pleased that we were able to have you here in person. Thank you for that very informative session on the past, present, and future of AI, particularly for busting some prevalent myths about the scope and potential of AI, and for touching upon some of the ethical concerns associated with AI. Thank you so much. I would like to thank our director, Professor P.V. Sunil Kumar, for his constant support and encouragement. Special thanks to Dr. Afzal for help with the memento, Sunil for putting together the poster for today's event, Dr. Kritika and members of the website committee and media cell for timely updates and dissemination of information, Biju, Soju, Sumesh and their ever-dependable CFET team for IT support, the staff of the director's office for logistics support. I would also like to thank Professor Jagdish Berry for leading our efforts this academic year in coordinating this colloquium series. Lastly, thank you to the audience, both those who are here in person and those of you who are attending online. Our next talk in the series is by Professor Aditi Lehri. This is scheduled for the 25th of February 2022 at 3:30. More information about the speaker and the talk will be sent to you closer to the date. Thank you all and have a good day.